value, which actually isn't a value at all, but rather an indication that the column has no value. So null is nothing, or a non-value rather. Null is typeless, so you can use it for any kind of data type. You can use it for integer, decimal, date, and so on. And another approach is to use default values. You can say that for this table, in this column, if no value is added, use this default value, and then it's added.
Okay. So that is determined already when you create a database schema?
Yes, exactly, when you construct your tables.
So then you could say whether it's allowed to use null values or what kind of default values will there be and so forth.
And when to choose null or default, it depends on the situation. But you also always have to be aware of the outcome of a query from the table, depending on you use null or default values. Let's say, for instance, if you use some sort of software and the software gets an unexpected null value, it might stop with an error and so on.
Yeah.
A little about transaction. This is something that's used mainly in larger database systems. We have several users concurrently using the database. A transaction is a series of operation that's done through the database management system. And it can be insert, update, and so on, all within one transaction. It can be 1, 3, 4, 5 or more operations. The idea is that within this transaction, all these operations are totally separated from other transactions. So you make a series of operations, and these has nothing to do with another series of operations and might concur at the same time. So they can never interfere with each other and destroy the integrity of the database.
So this is sometimes called atomicity. If you make similar with the atom, you cannot divide the atom, and the transaction should never be divided into different parts.
So the transactions ensures that the integrity of the database is maintained. As we said, all or nothing of the transaction is performed. If something fails within one of these operations within a transaction, everything is cancelled and goes back to the original state. And there's usually no point of use in transactions in a single database application.
Okay. Well, I say most database systems are really multi-user systems.
Except for Access, which is a one-person database.
Okay. We will come to that later on when we talk about different systems.
Yeah. So, why do we need transactions? Well, the integrity of a database is very, very important. Without it, you cannot trust the data that comes from the database. So, you need some sort of systems to make sure that we always have the integrity of the database. And possible reasons why this would not be the case could be power failure. If the power disappears just at the exact moment when you're making a transaction or an operation to the database, you don't really know if it was successful or not. Or maybe some of the operations were successful, but not all of them, which may cause the inconsistency of the database. And same thing if hardware will fail, like the hard drive will maybe break down.
Okay. So it's something to guarantee the quality of your data, in other words. Yeah.
And also there could be erroneous user operations, deliberate or not. We all make mistakes, we're all human, so that's some reasons why we need transactions. And here are the properties of a transactions. They're shortened down to the ACID properties, which stands for A, the atomicity, as we said before. A transaction cannot be divided. It's do everything or nothing sort of state. So the database management system guarantees that all of none of the operations are executed.
Yep.
Then we have the consistency. The database is in a legal state before and after a transaction. So within the transaction, some things might go wrong, like the power fail or so on. But before and after the transaction, the database is okay.
Yep.
It's consistent. We have the isolation. No transaction outside the current transaction can see data in an intermediate state, which means if you have one transaction that is updating a record and another transaction which is just reading.
The reading can only see before and after.
Exactly. It cannot see anything that's within the transaction or in an intermediate state.